Lecture 10, Discrete Probability Distributions.
In this lecture, we will talk about discrete probability distribution for a random variable, and the mean, variance, and standard deviation for a discrete probability distribution, and the hypergeometric distribution. Now, a random variable, usually given as big X here, capital letter X, is a variable whose possible values are numerical outcomes of a random phenomenon. So basically, it's a variable whose values are determined by chance. A random variable can be classified either discrete or continuous, depending on the numerical values it can assume. So if it takes like 1, 2, 3, generally it's discrete, but it has like 1.01, 1.001. I mean, if it takes this type of values, it's generally continuous. Now, in this lecture, we'll concentrate on discrete random variables and their probability distributions, but the continuous random variables will be given in chapter 6.
A discrete random variable is a random variable that can take only countable number of distinct values, such as 0, 1, 2, 3, 4, and it's generally whole numbers. And some examples of discrete random variables: the number of traffic accidents in a city, number of cars in a parking lot, number of heads obtained by throwing a coin 3 times, number of defective engines, number of customers entering a restaurant during a certain hour. And a probability distribution is said to be discrete if it's a function of discrete random variable. Now, the probability distribution of a discrete random variable lists all the possible values that the random variable can take and their corresponding probabilities. So we do it generally with a probability table. And this here, this row, the first row, is listing all the values that X can take. And we say this is X1, X2, X sub n. And now the second row is showing the probability that this X, the big X, can take the value Xi. So these, we are listing the values the big X can take and its probability. Now, and by using this, okay, one important thing is, and sometimes we can use PIs here, and mostly, but in most books, it gives probability as probability that the random variable is equal to Xi. So we use this notation most of the time. And the probability diagram can be obtained by using the table. It's just another way of showing the probability distribution. So for the X values, we find the probability for P1. So this is for P2, and this is for P3. So they're saying the same thing. It's almost same thing with the table. Now let's look at this example here. In the experiment of tossing a coin 3 times, construct a probability distribution for the number of heads. Now let's think of the sample set first. I mean, sample space. When you throw a coin, these are the outcomes you have: the head and tails. Now here we will construct a probability distribution for the number of heads. So in this case, our random variable X, the big X, will be the number of heads. And when you look at the sample space, you can understand this. X takes the values 0, 1, 2, or 3, because 0 means like no head, and this is possible if it's all tails. And we have 3 here. This is possible for this outcome, 3 heads. Now we will try to calculate the probability of each. So the probability of getting X equal to 0 it means no head, it means 3 tails, and this is one outcome in 8, so that its probability is equal to 1/8. And in the same way, we can find the probability of getting one head only, and these are the 3 cases here, 3 outcomes having this property, and the probability is 3/8. And for 2 heads, we'll list the outcomes and divide by the all. So it will be 3/8. And for 3 heads, we have only one outcome, satisfying this and divide by the all outcomes, which is 8. So we get these probabilities and we can list them in the table. This is the probability distribution of X. Now, um, by using the same table, we can construct the probability diagram. So we list all the values of the random variable X, and then corresponding probabilities. This is 1/8, and as you see here, this is 3/8, and the rest is same. We have 4 random variables and 4 values of random variable and its probabilities given here. Now we will see the requirements for the discrete probability distribution. Not all distributions are discrete probability distributions. So there are 2 important requirements here. You have to check first the sum of the probabilities of the values assigned to X in the sample space must be equal to 1. So it means the probabilities for each value, when you add them, will be equal to 1. And the probability of each value of X in the sample space lies between 0 and 1. So the probability of a value should be between 0 and 1.
Now let's look at this activity. Determine if the following are probability distributions. Now let's have a look. So these are the values of X, and these values, we cannot do anything about them because they are depending on the experiment, and since the experiment is not given to us, we cannot discuss their situation. If they're okay or not. So we'll just simply look at the probabilities here. All the probabilities are less than 1. Okay, all less than 1. That's good. And their sum is equal to 1. Yes. So it's a probability distribution. So when it comes to this one, the second one, we cannot have a negative value for a probability, and we cannot have it more than 1.5, more than 1. So it cannot be a probability distribution. So here, all the values are less than 1. Okay, good. And sorry. And then when you add them, it makes 1. So for this reason, we will say this is a probability distribution. And when we look at here, they're all less than 1. That's good. But when you add them, it will get you 1.2, and this is not 1. So for this reason, I will say this is not a probability distribution. So here are the answers. Now let's look at these examples. Find the value of A for the following discrete probability distribution. Now here is the discrete probability distribution. So we know the sum of the probabilities will be equal to 1. So we can directly say A plus 0.25 plus 0.5 is equal to 1. So this will give you A plus 0.75 is equal to 1. And this will give you A is equal to 1 minus 0.75, which is 0.25. Now let's look at this example. A salesman estimates the probabilities given in the following table for the number of cars sold per week. So this becomes our random variable X. And the probability distribution is given in this table, on this table. Now we will try to answer the following questions. Find the probability of having more than 3 sales per week. So now let's write it as the probability function, like the probability X, the random variable. Okay, it will be more than 3 cars sold. 3 sales, more than 3 sales means the number of cars sold per week is bigger than 3. So in a discrete probability function, the distribution, you have to count all the values of the random variable which are bigger than 3. So it might be x equal to 4, and it might be px equal to 5. So then when we look at these values, we can add them, and it will give you 0.22. Now, find the probability of having at least one sale per week. Now, this is the probability. Okay, let's write it. Having at least one sale means the number of cars sold are at least one. It means more than one or equal to one. So in this case, more than equal to one, it means it might be equal to one. It might be equal to 2. It might be equal to 3. It might be equal to 4. It might be equal to 5. But we can use a shortcut here instead of adding all these. We know the big sum here is 1. So we can write here 1 minus. So we can remove this one, the probability x equal to 0. And this will give you 1 minus 0.05, which makes 0.95. What's the probability of selling at most 4 cars a week? In a week? Okay, we can write this one as, again, at most 4 means the number of cars sold will be less than or equal to 4. So in this case, again, it might be equal. It might be 0, 1, 2, 3, and 4. So instead of adding all these here, we can use again the complement rule. We know that the sum of the probabilities, all the probabilities equal to 1. So instead of calculating these 4 or 5, yes, these 5 probabilities, we can say their sum is 1. Let's subtract the probability that x equal to 5. So it will be equal to 1 minus 0.07, which is 0.93. Let's look at the mean and variance and standard deviation of a discrete probability distribution. Now, mean is also called here the expected value. So the expected value of a discrete random variable of big X, capital letter X, will be denoted by mu or E of X, and it is calculated by X times the probability of X. So this little x here is the values that the random variable takes. Now you can assume you can take this one as the frequency or the weights here. You can take this one as this is like weighted mean. If you remember weighted mean, it's like xi, wi. Now wi here is like take this one as the probability of xi. So in this case you can write pxi. Now in the same way we can define the variance. The variance of a random variable. X is the real number given by, it's denoted by V of capital letter X or sigma squared, and its formula, it can be calculated by this formula, the expected value of x squared minus mu x squared, or if you reduce it, if you do some more calculation and you can show this is equal to uh, the sum of x squared times px minus mu squared. So we generally use this rule here. And as usual, the standard deviation is defined by the square root of the variance. So you will find this one and you will put it here and take the square root and you will get the standard deviation of random variable of x. Random variable x. Now let's look at this example. The probability distribution below corresponds to the number of breakdowns for a machine during a given week. Breakdown means like here the problems, it stops working and it shows the problem. So or more. Uh, we look at this distribution of x. So the x is the number of breakdowns. This big X here is the number of breakdowns. So what does this mean? It means the probability that the machine does not make any breakdown is 0.064, and the machine gives breakdown 3 times. The probability of it is 0.216. Anyway, let's find the number of breakdowns here. If you remember, the number of what's the mean number of breakdowns? It's like the expected value of x. So it's asking here mu, or it's asking the expected value of the random variable x here. So what is it? So it will be just, let's write the formula. The formula for mu or e of x is just x times p of x. So in this case, we will have the x value 0 and its probability 0 times 0.064 plus 1 times 0.288, and then plus 2 times 0.432 plus 3 times 0.216. So then you can use a calculator to find the solution here. So you will get 1.8. So we can say the number of the mean number, the average number of breakdowns here is 1.8. You can say 1.8 breakdowns are expected. So this is an expected value. You can say expected in a week or in a given week from the machine. Now let's look at this example here. The following table represents the probability distribution for the number of messages received per hour over the computer network. So here are the number of messages and here are the probabilities. So let's give an example how to read this table. So it means the probability that we get 13 number of messages over the computer network per hour is 0.02. So find the mean, the variance, and standard deviation of the number of messages per hour. Now we have the probabilities here, and we have the values of x, the random variable. We can use the formulas here, and here the formula. Now we'll find the expected value of x. Here I put the table here so that we can follow the numbers here. So as we know, it will be just the sum of the products of the x values and the probabilities. So if you look at here, it's 8 times 0.005, 9 times 0.3. So you see each of them. So it will give you 10.12. So that means the expected value of the number of messages received per hour is 10.12. and the variance of x. So we have a formula for it again. So we multiply. Okay, let's see. This is x squared. This is x squared, and the value x takes 8 squared times its probability 0.05. So this will be done for all of them, and they will be. I mean, we will add all of them. So 9 squared times 0.3, 10 squared, so up to 13 squared times 0.02. And we are done with this part here by this part. We do it here. And then mu, we got it, it's 10.12, so we take it squared, so it will be 1.385. And now, what is the standard deviation? The standard deviation is, of course, the square root of the variance, and you take the square root of it, and we get this one. Now, let's do this example. A company has established statistics on the interventions necessary for the maintenance of machines for 1 year for 50 identical machines. It's obtained, so the table below is obtained. So the number of interventions means like either it gives a problem or it requires a maintenance. You go to the machine and you do something to the machine. So we say this is just an intervention. So we have 50 machines here, and the statistic shows 4 machines with no intervention. So 4 machines, they didn't need any intervention, so it means they don't have any problem. But 25 of them, we went to them one time, and 12 of the machines, they required two times intervention. 6 of the machines, they needed 3 interventions, so it means they have more problems. And 3 of the machines needed only 4 interventions. Now, as you see here, this is not a probability distribution here. This is not a probability distribution. This is not a discrete probability distribution because we don't see any probability here. No probability. So how will we find the probability here? Okay, let's read the question first. Construct a probability distribution for the random variable x. And here, of course, we have to, this has to be given to us. Okay, now I'm giving it. X is, okay, take x, the number of interventions. It's kind of clear from the question, but still, we need to specify what is x. And find the expected value of x, find the variance of x, and standard value of x. So the first thing we have to do is, like, let's find the probabilities of each variable here. I mean, each value of the variable. So this will be x. Now, how can we get the probability for 0? So how many machines got 0 intervention? 4. Out of what? 50. So you have to divide each with the total. So you will get a probability distribution for x. Now let's see. So to construct this probability distribution, we have to divide the number of machines by the total number of machines. So when you divide by 50, you get these probabilities. Then we can calculate the expected value of the mean, the expected value of x. So this is how we calculate. You can make a table for it, or you just multiply these and add. Okay, here is another way to do it with a table. So you put the probabilities and you multiply them. So, and then you got this, and you got the sum of them. So their sum will give us the expected value. So the number of interventions, the expected value of it, it's 1.5. So practically it means we expect one or two interventions mostly. Now let's look at the variance, and for the variance we need to calculate x squared times p of x for each. So this has to be, uh, so here this x squared, let me tell you, this is 0 squared times 0.08, and this is 1 squared times 0.5, and this is 2 squared times 0.24, and so on. And we will get the sum. Okay, we know the mu, okay, and we get the sum of this part. And now we can subtract this value, mu squared, so take it squared and subtract it from this value 3.8, 3.5. We'll get 1.0036. And now this is the variance, and now the standard deviation is, obviously, its square root, which is 1.0080. Now let's look at this example. Uh, 1,000 tickets are sold at 1 rial each for a cell phone valued at 500 rials. What is the expected value of the gain if you buy one ticket? So it's like a lottery, I guess. So there are 1,000 tickets are sold. You buy one for 1 rial, and if you win, uh, you will get a cell phone valued at 500 rials. So what's the expected value of the gain if you buy one ticket? So in this case, the gain is our random variable here. This x. X is the gain here. So we have to write a probability distribution for the gain. Now, the gain will take two values. Either we lose or we win. So in the case of winning, we will get 499 reals because we spent already 1 real for the ticket. So we will get 500 real, but we spend 1 real for the ticket, so it makes 499. Our gain is this. But if we lose, this is the win case here. If we win, if we lose case, this is when we lose one ticket, so it means 1 real. So let's look at the probabilities of happening. So what's the probability that we can win? It's 1 over 1,000. There are 1,000 tickets, and ours is only one ticket. And with 999 over 1,000 probability, we will lose. So in this case, how can you find the expected value of x, which is the probability times the value of the random variable 499 times 1 over 1,000 plus minus 1 real times 999 divided by 1,000. So it gives you negative 0.5 real. So what does this mean? When you buy a ticket, you most likely get negative, so you will lose. Now we will see an example of discrete probability distribution. It's hypergeometric distribution, but before the hypergeometric distribution, we have to review some of the topics. Now, one of them is k combinations of n objects. Uh, what is a k combination of n objects? A subset of k items of a set of n items is a k combination of n items. Now, here is an example. 1, 2, 4 is just a 3 combination of the set 1, 2, 3, 4, 5. So, are there more 3 combinations? Yes. 2, 3, 4, 3, 4, 5, 1, 3, 5. And
let's look at this example. Let's list all four combinations of the set 1, 2, 3, 4, 5. So we are trying to find all the subsets of uh, the set 1, 2, 3, 4, 5 that has only four elements. So I will not write, but I will just give you the list. Now you can try to find it yourself. Now we have here 5 as far as I 1, 2, 3, 4, 5. Yes, 5 four combinations. There are 5 four combinations of uh, the set 1, 2, 3, 4, 5. And another way to ask the same question is this way: in how many ways can we choose two elements from the set A, B, C, D? Okay, let's try. I will try. Okay, I will not try. Just if you try to choose some elements and two elements from this set, you can make this list like A, B, A, C, A, D, B, C, B, D, C, D, and it gives just 6 elements. Six we can choose in 6 ways. Now, how okay, do we have to list all the time? So how can we calculate these the number of the ways or the number of the subsets or k combinations? We have a formula for it. The number of ways of choosing k elements from n elements can be found by this formula here: n factorial divided by n minus k factorial times k factorial. And sometimes we use this notation. N choose K or N choose K, we can write this way. So this is denoting the K combination, the number of the ways of K combinations of N. So it means the number of K combinations of N. Now here, factorial, this exclamation mark is N times N minus 1 up to 1. It multiplies all the numbers from 1 to n. Now, one other thing here is 0 factorial is just 1. Now, let's try to use this formula to get 6 here. So how many elements we have? 4, and we want to choose 2. So according to this information, it has to be 4 choose 2. And let's try this 4 factorial, 4 minus 2 factorial times 2 factorial. And 4 factorial is 4, 3, 2, 1. So it will be 24 divided by 2 factorial, 2 factorial. 2 factorial is just 2. So you can take this one as 2 and 2. So when you do this calculation, you will get 6. And here is 6. So you can do the same thing here. 4 choose 5 choose 4. What is it? It's 5 factorial. 5 minus 4 factorial, and times 4 factorial. And what is this? 5 factorial is just 5 times 4 factorial, and divided by, this is 1 factorial, which is 1. This is 4 factorial. You can, after the simplification, you get 5. As you see, we have only 5 for combinations here. So this formula is calculating the number of k combinations of a set that has n elements, or the number of ways of choosing k elements from n elements. Now, after this,
Now, before starting hypergeometric distribution, we will try to define its random variable. So its random variable, we can tell it in this example here. So assume in a bag you have k items type 1 and n minus k items type 2. So there are two types of items in a bag. So in total you have big N number of items, and you choose, you draw like little n items. So the question is, what's the probability that little x of n drawn items is type 1? So we will try to find this probability, and the number of type 1 items here out of n drawn items is making the hypergeometric distribution random variable. Now here is a situation in official terms. Now, what is the answer of this question? It's
it is given by this formula here. And how will, okay, how can you understand it, or how will you get it? Uh, you will do it this way. I mean, each time if you do it this way, then it will be easy to do the things. So if you chose n, this total is n, total is big N. Now the probability you can, okay, here if you choose n and x items, so what we are trying to find the probability x items is type 1. So we choose, assume we choose x item from k. Now, and n minus x, so the rest of n items will be n minus x type 2. So we are choosing x from k. So in how many ways we can choose x from k? It corresponds to this number here, the number of ways we can choose x numbers from k numbers. And in how many ways we can choose n minus x items from n minus k items. And this is what we write here. This is the number of ways of choosing n minus x items from big N minus k items. When we multiply, we get all the possible outcomes having this uh, property, x type 1 and n minus x type 2. And we divide by the total number of ways of choosing n from the big N. So we write it here. So then when solving the problems, it's better, you use this scheme here. Just say how many items we want from k items, how many items from n minus k items, and in total, how many big N are there, and how many choose from the back. So we put it here. So this gives the probability distribution for each value of x. We can have 0 here, we can have 1, 2, up to where? Up to k items. So this makes a probability distribution function for 0 to k. Now we call this one hypergeometric distribution. So in this type of question, you can use that formula directly. So this the distribution corresponding to this random variable is called hypergeometric distribution. Now let's look at this example. So a store has 6 TV graphic magazines and 8 news magazine time magazines on the counter. If 2 customers purchased a magazine, find the probability that one of each magazine type was purchased. So, okay, we can try to think of it as a back problem. Again, 6 TVs here, 6 TV magazines, and 8 news magazines. And then 2 customers are purchased a magazine, so 2 chosen here, 2 magazines are chosen. So the question is, find the probability that each magazine type was purchased. So it means when the customers bought, I mean, each one buys a magazine, so it makes 2 magazines. And we want one TV, one customer bought the TV magazine, and the other one bought a news magazine. So how can we choose such thing? So indeed, let's say this is the X, our random variables TV magazine, let's say. So we want one TV here. Okay, one TV means one TV and news because we are choosing only 2 magazines here. So obviously the all outcomes will be there are 18 magazines here, and we choose magazines. So we choose two of them, so it will be total 14 choose two. Okay, and how many TVs we can, how many one TV magazines we can choose from? Six. So it will be six choose one, and then multiply one news magazine from eight. So it will give you a choose one. So you can think of this way here. Indeed, you are choosing one TV from here and one news magazine here. And these are the possible ways of choosing them, and then divide by all the ways of choosing two magazines. So if you want to see a good writing here, it's easy to read here. So the answer is 48 over 91. Now let's look at this problem. A box contains 8 red balls. Okay, I will take it as an urn and not box. Anyway, 8 red balls and 5 black balls. And 2 balls. So 3 balls are selected, and we want, okay, find the probability that 2 balls are black. So 2 balls are black, and 1 ball is red. So you're choosing three balls, but you want them to be 1 ball red and 2 ball black. 2 balls black. So you can find the probability. Okay, you can say this is X here. I mean, if you want to use the formula, just you have to say one of them is X. I will say this is 1 ball is red. In practice, you don't have to say anything to, you don't have to assign anything for X. But if you want to use formula, you have to say X. And it will be, okay, how many 1 balls you can choose from? 8. So 8, choose 1. It's a number of ways we can choose one ball red from 8. And the number of ways of choosing 2 out of 5. For the, yeah, so we found the ways of choosing 2 blacks from 5 blacks. And now, what is the uh, number of ways of choosing 3 balls from the total? So total is 13. So you choose 3 out of 13. So it means 13 choose 3. So you can write here 1 ball red or 2 black. Uh, it depends. It depends on you. I mean, you can choose, but the answer will be the same. So let's see the answer here then. Suppose in a bag there are 5 banknotes of 5 real and 7 banknotes of 10 real and 10 banknotes of 20 real. If 8 banknotes are chosen randomly and each one has the same probability to be caught, what is the probability of not choosing any banks from 5 real? Any banknotes of 5 real? Now, okay, we can visualize the situation like this, okay. Now in a bag, there are 5 banknotes of 5 stars, 5 stars here, and 7 banknotes of 10 reals, and 10 banknotes of 20 real, Now, we choose 8 banknotes from here. Now, we want the probability of not choosing any banknotes of 5 real. So we can think of this question this way. Uh, Assume we have this 5 reals and not 5 reals, like two types, type 1, type 2. And here we're choosing 0 banknotes, 0 5-star banknotes. Now, not choosing, it means like not choosing any 5 real. And here we're choosing, um, okay, if 8 banknotes are chosen, so 0, 5 reals, then 8, 10 real, or 20 real, it will be. So in this case, the probability of choosing only choosing 0 of 5 real is this then. The probability is equal to the probability of choosing 0 out of 5. Sorry, the combination 5 choose 0 times the probability of choosing 8 out of 17. And in total, the total is here. The total amount is 22 banknotes. So the sample space has 8 banknotes chosen, 20 from 20 banknotes. So we have to write here the number of the ways of choosing 8 banknotes out of 22. It will be 8. Okay, 22 choose 8. Now, this one is equal to 1, so this is easy to see because C50 is equal to 5 factorial divided by 0 factorial times 5 minus 0 factorial. And we know 0 factorial is 1, so it will be just 1. So we don't have to write this one, so this will be 1. So the answer will be, an answer will be 17 choose 8 divided by 22 choose 8. So since this is 1, we don't see it here. Okay, this is because this is 1. So the answer is 0.076. So this gives the answer of the first one. Now let's look at this. What's the probability of obtaining only banknotes of 20 stars? So in this case, it's asking now the probability of choosing only 20. We have so let's do it this way. Now you can think this now for this one, for the second question here. You can think two groups, type 1, 20, and type 2, not 20. So from 20, it contains only 20 reals. It means you choose 8 banknotes of 20 reals. And from this set, you choose only 0. Okay, 0, 5 real, or 10 real. So so from the hypergeometric distribution probability formula, this is just 0 choose. Okay, now we are choosing 0 from 12. So 5 plus 7, it's 12. Now choose 0 times 8 out of 10. So it will be 8, 10, divided by, again, 8 banknotes from 22 banknotes in total. So it will be 22 choose 8. So again, this one is, if you calculate, this one will be 1. And so we can write the answer here. 10 choose 8 divided by 22 choose 8, which is equal to, so this is equal to 0.0001. Now, in this problem, as you see, sometimes you can use one group here, even there are 3 groups, so you can, depending on the question, you can say, this is one group, this is the other group, type 1, type 2, or you can choose any of them, depending on the questions here. Let's look at this example. A box contains 24 bulbs, of 4 of which are defective, and if 4 are sold at random, find the following probabilities. Now, 1, exactly 2 are defective, 2, none of them defective, all of them defective, and at least 1 is defective. Now, okay, let's try to visualize the situation. Now we have, again, a box or bag. Okay, we can take it a bag. So there are 24 bulbs, 4 of them are defective. So there are 2 types here. There's 4 defective bulbs, and you can say 20 good bulbs. Now, so if you ask here bulb, what is bulb here? So you can say this is like something like this. What here is, light. Anyway, now we have in total, its total is 24 bulbs. Now we choose or we sell 4 of them. So you can say here 4 chosen or sold anyway. Now, okay, we want to find exactly 2 are defective. So the probability that 2 defective. So if 2 are defective out of 4, it has to be and 2 good. So what's the probability that if we choose 4, so what's the probability that 2 of them is defective and 2 of them is good? So you can, okay, we can answer this question. Like here we choose, okay, 2 defective from 4, and we choose 2 defective, the good from the good ones, 20. So the probability will be equal to, if we use the hypergeometric distribution, I mean, we can use it here. It has to be 4 choose 2 times 20 choose 2 divided by 24 bulbs in total and 4 is chosen. It has to be 24 chosen 4. Now if we calculate this one, the probability here will be okay, this will be equal to 190 divided by 1771. So you can do it with a calculator. Now this was the answer of 1, and now the second one. So the second case is none of them are defective. So in here, the second case is none of them are defective. So it means we are looking for 0 defective and then 4 good bulbs. So it means from here we choose 0. From here we take 4 of them. So what's the probability? The probability here will be, okay, 4 choose 0, and then 420 choose 4, and divided by for 24 choose 4. And this will give you 1661 divided by 1771. Sorry, this has to be 5 here. I noticed that. Okay, now let's look at the third one. The third one is all of them are defective. Now 4 chosen, and all of them are defective. So all of them are defective means like we have the probability we are trying to find for defective and 0. We can say and here, no problem. 0 good bulb. Now, what's the probability? So we choose 4 out of 4 here and 0 from here. So the probability will give you, probability will be 4 choose 4 times 0, 20 choose 0, and then divided by 24 choose 4. And this will give you 1 over, this is 1 over 10,626. Now let's look at the last one. So it's at least one defective. So at least one defective. So we have to write this one now. The fourth. At least one defective. So what does this mean first? Let's write it. At least one defective means it means one defective and 3 good plus 2 defective, 2 good, and then plus 3 defective, 1 good, and maybe all defective here, 4 defective and 0 good. So, but this will take a long time to calculate. So for this reason, it's better to go with the complement of this. So if you look at this, what's the complement of this? The complement of this is the opposite of at least one defective means no defective. So we can write this one as 1 minus with no defective. And what does this mean? No defective means 0 defective and 4 good. So in the same way we calculate, okay, for as in the previous cases, we choose 0 from 4 and 4 from 20. So this has to be 4 choose 4 0, 4 choose 0 times 20 choose 4, and divided by, again, 24 choose 4. Now we calculate this one, and then we put it here and we calculate the probability. Now if we calculate with a calculator, this will be equal to then 0.455, and then okay, then if we put it here and here, this will be 1 minus 0.455, which is equal to 0.400, no, 0.545. So the answer will be this. Okay, this is not related anymore. Okay, this is how we solve it. That's it. 1. The probability distribution of a discrete random variable x is given below, and I think this is an extra here. So find k. So we know that the probability, the sum of the probabilities should be equal to 1 if it's a discrete probability distribution. So when you add them, I mean, it will be equal to 1. So let's add them and make it equal to 1. And in this case, it will be 5, 7, 12 plus 9, 21, 21 plus 11. It will be 32 over k equal to 1. So from here you can say this k is equal to 32. So it's the answer is C. Now suppose that we have a discrete random variable x with the distribution given in the below table, and the mean and the variance of x are given by, okay, we have to find the mean and the variance. Now if you remember, the mean is equal to the sum of the products of the values of x times the probability of these values. Now it will be 0 times 0.25 plus 1 times 0.4 plus 2 times 0.35, and which gives us 0 plus 0.4 plus 0.7, and which gives you 1.1. So without going too further, we can just say this is the correct answer here. Mean is 1.1. And if you want to calculate the variance here, okay, let me show you how to calculate the mean here. The mean is x squared times px, and the expected value of x squared minus mu squared. So in this case, it will be this part will be 0 squared times 0.25 plus 1 squared times 0.4 and plus 2 squared times 0.35 minus mu squared, which is 1.1 squared. If you do this calculation here, I think this part will give you 0.4 plus 2 squared is 4, so it will be 1.4 minus 1 point. When you take the square root, the square, it will be 1.21, so it will be 1.8 minus 1.21, which is 0.59. So we get this one. These are all squares here, not 2, by the way. These are squares here, like here. 3. For the following probability distribution, find the value of A and B if mu is equal to 1.7. Now, if you remember, mu is the sum of the products of the values of x and its probability. So it means 0 times A plus 1 times 0.5, 0.15, sorry, 2 times B plus 3 times 0.25 is equal to 1.7. That's one thing. So this will make here, this is 0 and 1.7 plus, and 1.7 will be equal to, this is 0 now, 0.15, and this is 0.75, so it will be 0.9. So 0.9 plus 2b will be equal to 1.7, and it means 2b is equal to 0.8. So 2b is equal to 0.8, and then b should be equal to 0.4. Now, how can we find A? Now, we can use the fact that the sum of the probabilities will be equal to 1. So in this case, A plus 0.15 plus b, which is 0.4, plus 0.25 is 1. So in this case, you can find a to be 0.2. So then it will be D. Now, a survey of Amazon.com shoppers reveals the following probability distribution of the number of books purchased per hit. What is the probability that an Amazon.com visitor buy at least one book? So this is the number of books here. I guess this is the number of books. And this is the probability of each. Now, at least one book means the probability that x is less than or equal to 1. I'm sorry, bigger than 1. So we have to calculate x equal to the probabilities up to, we will add all the probabilities from 1 to 7, but this is hard and then this is long. So instead, we can, instead of adding all these, we can use the complement. This is 1 minus x is less than or less than 1, which is 1 minus p, x equal to 0. So it will be then 1 minus, I will use here 1 minus 0.35, so which is 0.65. Which of the following represent a probability distribution for a family of 3 children? Your x represents the number of boys. So let's look at the sample space for the gender of 3 children in a family. They might be all girl, and 2 girls and 1 boy. And here might be first girl and then boy, then girl. It might be then boy, girl, girl, and then 2 boys and girl and 1. Okay, the first girl and 2 boys and boy, girl, boy, and the last one is all boys here. So there are 8 possibilities. So if there is no boy at 0, okay, there's a possibility that it's x equal to 0. In this case, the only option here is all girls here. It's 1 out of 8, so the probability will be 1 over 8. So for x equal to 1, there will be one boy, 1, 2, 3. So it will be 3 out of 8, so it will be 3 over 8. And for 2 boys, we have these 3 cases. It will be 3 over 8. And 3 boys, it's 1 over 8. So it will be just B. Now let's look at this one. Which of the following represents a valid probability distribution? So they have to be all between the probabilities. They have to be between 0 and 1, and their sum should be equal to 1. So this is okay. And here, when we look at here, their sum is okay. They're all between 0 and 1, and let's check their probability, their sum. So these all 3 over 10. So it will be just, so it will be 7 over 10 plus 3 over 10, so it's just 1. So they're both probability distribution. Now, for the following probability distribution, find the probability of x more than or equal to 2. Okay, I think these are missing here, so I will just say this is 1, 2, 3, 4, and 5. So in this case, okay, I will estimate this way. So the probability that x is bigger than or equal to 2 gives you the probability of x equal to 2, 3, and up to probability x equal to 5. So, but I can use, so we have to add these, but instead I can subtract the probability that x equal to 1. This will be 1 minus 0.3, which is 0.7. That will be just d. 9, 8. The probability distribution of a discrete random variable x is given below. Find k. So here the sum of, we know the sum of all the probabilities here is equal to 1. So this has to be 6, 4, 15k is equal to 1. So k is equal to 1 over 15. Let's see then. Question 9. 3 statistics professors and 7 chemistry professors are available to be advisors to a student organization. The student organization needs 2 of the professors to be advisors. Each professor has an equal chance of being selected. What is the probability that both professors are chemistry professors? So if you remember it, remember the hypergeometric distribution. We have a set here, a set of 2 types of items. So here we can think the statistics 3 stat professor, and there are 7 chemistry professor, and they're available, and we will choose 2 of them. So the question is, okay, what's the probability that both professors are chemistry professors? So we choose 2 chemistry professors. So now here, what's the probability? If you remember the hypergeometric distribution, how we calculate this probability is we look at here 2 chemistry professors, that they're both chemistry, and it means 0 statistic professor selected and 2 chemistry selected. So then we will find we will apply the formula in how many ways we can choose 0 statistics from 3. So 3 choose 0. These are the ways of choosing 0 statistics, and then from the stat professors, and the 2 chemists from 7. So it will be 7 choose 2, and then the total number of professors is 10. So we are choosing 2 out of 10. So it will be 10 choose 2 here. And when we calculate this one, you can use a calculator, or you can directly use the definition of it. So this is just 1 I know, because 0 combination of any set is 1. It has only 1 element. 1 times, what is this? 7 2. 7 2 is 7 factorial divided by 2 factorial times 5 factorial. So 7 minus 2. So this has to be, okay, 7 times 6 times 5 factorial. So 5 factorial, they cancel. You'll get 21 here. So this is 1 times 21 divided by 10. Okay, 10 choose 2. This is 10 factorial, 10, 9, 8 factorial divided by 2 factorial times 10 minus 2 factorial, which is 8 factorial. So 8, 8 cancel, so you can calculate this is 45. So this will be just 21 over 45. I think here it will correspond to A. When parking a car in a downtown parking lot, drivers pay according to their number of hours. the probability distribution for the number of hours of a car is parked as given below. So this is 1 hour, the probability is 0.28, in 2 hours 0.38, and so on. So let's answer the following questions according to this this probability distribution. What is the probability that a car will be parked in this parking lot for at least 2 hours? So it means the probability x is at least 2 hours, means x is bigger than 2, or x bx bigger than or equal to 2. So in this case we have to add these, but instead of this one we can subtract 1. Okay, subtract the probability of x equal to 1, so we can use the complement here. So this will give you 1 minus 0.28, which is 0.72. So it will be 0.72. Now, what is the probability that a car will be parked in this parking lot for at most 3 hours? So Bx at most 3 means that will be less than or equal to. And again, we have to add all these, like 3 of them. So instead, I will use the complement. I will use this one. So this is 1 minus the probability x equal to 4, and which is 1 minus 0.13, which gives you 0.87. Because each time I'm using the fact that they're equal to 1, their sum is equal to 1. So what is the expected number of hours a given car will be parked in the parking lot? So the expected value of x is equal to the sum of x times p of x. Now we can do it here. 1 times 0.828 plus 2 times 0.38, 0.676, and 3 times this one, it will be 0.63, and 4 times this one, it will be just 0.52. Then when you add them, it will give you, it will be just 1.04, 1.67, and with 52 we got 9, 1, 2. Okay, it will be 2.19. If I'm not wrong, it has to be 2.19. So the variance, for the variance, let's remember the variance formula. The variance formula will be the variance formula sigma squared is equal to the sum, okay, the expected value of x squared, which means the sum of x squared times px minus mu squared. So let's try to calculate this one. Okay, it will be x squared times 0.28. So this is, okay, I'm trying to calculate this one now. 1 squared times 0.28 plus 2 squared times 0.38 plus 3 squared times 0.21 plus 4 squared times 0.13 minus mu squared, which is here 2.19 squared. And when we do this calculation, equal to 0.9739, and this is the standard, this is the variance, 0.9739. Now what is the standard deviation? We know the standard deviation is the square root of the variance, so it will be equal to square root of 0.9739, which is equal to 0.9867. Question 3. 1,000 are sold at 1 real each for 4 prices of 100 reals, 50 reals, 25 reals, and 10 reals. The winning ticket is returned to the pool of tickets after each draw, And now what is the expected value of your gain, let's say, of your gain, if you buy one ticket? Now here, the gain will be equal to what? Gain is your price if you win, and then minus your ticket value. Now, let's say this is x, the random variable gain is price minus 1. So the price can be what? You won 0 or you won 10 and you won your 25, 50, or 100. So these are the possible prizes you get. I mean, you will get 0 or the others. Now we can make a, okay, to find the expected value, you need to have the probability distribution for x. Now I will put it here. So I will say this is x. You can get here 0 minus 1 and 10 minus 1 and 24 minus 1, 25 minus 1, and then 50 minus 1, and then 100 minus 1. So now we have to find the probability of x, okay, for each. Now, so here we have to check winning, so we have to check the price here. So we won 0, so we have to check the probability of winning 0 here, winning 0. So you can think this way, like we will assume here we have drawing for 10, then 25, then 50, then 100. So assume your ticket is 5. So to get only 10, so to get 0, so to get 0, winning 0 probability, we will try to get this one. So it will correspond to this one here. Okay. Now, what's the probability of getting 0? Getting 0 means here we don't get not 5, not 5, not 5, and not 5. So they're all independent events because there's replacement here. So the tickets are returned to the pool after each draw. So it has to be, they're all independent. Getting that 5 here is 999 over 1000. So since they're all independent, so we will find the probabilities and multiply all. So the probability of getting 0 means if your ticket is 5, getting net 5 in all drawings. So it has to be, the probability will be then 999 over 1000, the fourth power. Now, winning 10, prize 10. Okay, how can it happen? Let's say again, your ticket is 5 here. Again, now how can we get 10 here? It means you're getting 10. You will get, I mean, we'll get 5 here, and this part, it's not important for us because when we get the ticket, if we win, we will get 10 real, and we will go, and for the others, we cannot use the same ticket. So we will just check these. Check this one here. What's the probability getting 5 out of 1000 tickets? It's 1 over 1000. And for the others, any number is fine for me. It guarantees if this happened, 5 happened, then no matter what happens in the other one, it guarantees our winning. So the probability of winning is 1 over 1000 for winning 10. Now winning, so this means this is now the gain for winning 0 is 99. Probability is this. Now winning so for winning 10, this is the probability for the gain. And for 25, if you win 25, so what's the probability? Now again here, let's look at here again. So we are checking now winning 25 thing, winning 25. Winning 25 means like you didn't win 10 with 5. Okay. If you won, you wouldn't go for 25. So then you won 5 here and you bought the prize and you left. And these not important for you. Whether they are 5 or not, it's not important because you won 25 and you left. So in this case, what's the probability of getting not 5? It's 999 times what is the probability of getting 5 here? It's just 1 over 1000. Now what happens here is guarantees are win here. They're not very important as long as this happens. So then the probability becomes here is 999 over 1000 squared. So then you can write here the probability of winning 999, winning 25 is 999 over 1000 squared. Now winning 50, what's the probability? So we will calculate the same way here. Assume your ticket is 5. How can you get winning 50? Winning 50, okay, we're looking at winning 50 now. For sure, you didn't win 5. And for 25, you didn't win 5 again. I mean, the drawing didn't show 5. But here, the drawing showed 5. And for this one, it's not important because no matter what happens here, you already got 5 and you won. Even it's again 5, it will not help you. So it will not change the situation. So what's the probability that getting 9, not 5 here? And here, getting that 5. And getting 5 here, only 1 over 1000. And here, it's even it's 5 or not, it's just 1. We get any number for sure there. So then the probability for winning 50 is now 999 squared divided by 1000 cubed. Now let's write this one here. Now winning 100. So let's try to do the same thing here. Your ticket number is 5. And you want to get, you want to see, okay, you winning 50, winning 100. So here it means if you will win the 500, then you shouldn't have 5 here. You shouldn't have 5 here because if the first drawing is 5, you got 10 real and leave. Okay, you don't wait for 100. So if you want to win, if this is the case, you will win 100. So you will not have 5. The drawing will not show 5. The drawing will not show 5. The drawing will not show 5. But at the end, the drawing will show 5 and you will get it. So what's the probability getting 9 here, getting 5 here? You're getting that 5. It's 9 999 over 1000. 999 over 1000. And I remind you, this is independent drawings because the returns replacement. It's a draw with replacement for 5. 5 in 1000 is just 1 over 1000. What's the probability of getting 5? It's 1 over 1000. So then we'll get the probability here is 999 cubed over 1000 to the fourth. Now this will give you this number here. Now we can write the expected value. And this calculation is here. This calculation assumes the drawing is done for first 10, and then 25, then 50, then 100. So it goes like this. And when you add all these, you will get 1. I mean, I checked it. So the expected value of x will be equal to what? Minus 1 times 999 over 1000 fourth plus 9 times 1 over 1000 plus 24 times 999 over 1000 squared plus 49 times 990 squared, 999 squared over 1000 cubed, and then plus 99 times 993, 99 to the cube over 1000 to the fourth. Like if you calculate all these, this will give you minus 0.8154. So your expected value is when joining such lottery, you don't expect to win indeed. So for one ticket, it is done this way, but for 2 tickets, it's much more complicated because in 2 tickets we can win 50 and 100 regal together, and 25 and 10. So it makes it more complicated, and it takes a long time to list all the possibilities. For this reason, I changed the question to 1 ticket, and this is the correct way of doing this with the assumption the first drawing is for 10 and the other one is 25, the other one is 50, 100. Okay, so this is the order of drawing here in my calculation. I assumed this. For a store has TV, 6 TV graphic magazines, and 8 News Times magazines on the counter. If 2 customers purchased a magazine, find the probability that each magazine type was purchased. So each magazine type purchased. So you can think of this as you can solve it by hypergeometric distribution. So let's assume in a bag we have 6 TV magazines, 6 TV, and 8 news. Now in total here, total is 14 magazines here. 14 magazines. Now it says that 2 customers purchased. 2 customers purchased. So T2 mags chosen, let's say. Now the question is, what is the probability that each magazine was purchased, each magazine type purchased? So it means, in this case, it will be 1 TV and 1 news magazine. So what's the probability that these 2 magazines are, one of them is TV, one of them is news? So here you will, okay, we will look at the number of ways of choosing one TV from 6 and one news from 8, and we will use it in finding the probability. This is equal to the number of ways of choosing 1 from 6 and choosing 1 from 8. So these are the ways of choosing one TV and one news. If you want the probability, you have to count all the possible ways of choosing 2 out of 14. So it has to be, here we have to divide it by 14, choose 2. And if you calculate this one will be 6 and this one will be 8. So you can calculate this by using factorial, its definition, or you can use a calculator. Okay, now I know these, it's because these are 1, so it will be 8 and 6. Now let's look at here. Let me do it here. 2 factorial times 12 factorial, because their sum should be equal to 14 here. Now let me write this one as 14, 13, 12 factorial. They will cancel out, and with 2 here we will cancel this. It will be 7. So this has to be 7 times 13, which is 91. So in this case, the answer is 48 over 91. So this is the probability that one of each magazine type was purchased. Now, a box contains 24 transistors, 4 of which are defective. 4 are sold at random. Find the following probabilities. So from 4 items, from 4 transistors, we want exactly 2 are defective, none are defective, all are defective, and at least 1 is defective. So you can again think of the hypergeometric distribution here, because the problem is it can be set this way. So we have a box of transistors, and how many good transistors? Like 20 good and 4 defective. So in total, that will be 24. So we are choosing 4 chosen, or 4 sold. You can say 4 sold, you can say here, sold or chosen. And then the question is, okay, we want exactly 2 defective. So exactly 2 defective out of 4 means like 2 defective, 2 good. So it means what's the probability that we will have 2 defective and 2 good. So it's like, this probability is corresponding to the choosing 2 good from 12, from 20, and 2 defective from 4. So we can write here the probability is the number of ways of choosing 2 from 20 times choosing 2 from 4, and divide by choosing 4 out of 24. So it means 24 choose 4. Now you can use a calculator to find this one. I don't know the exact answer, but let's write the answer in terms of combinations. It will be C20 choose 2 times C4 choose 2 divided by, so I will say divided by 24 choose 4. Now okay, let's look at B now. We want to find the probability that none are defective. So for B, none are defective means like we have 0 defective. If you have 0 defective, so it means you have for good. So you have good transistors. Now it means, okay, how can you find it? You will choose 4 good from 20 and 0 from defectives, 0 from 4. And now the probability will be equal to 4. You will 20 choose 4 times 0. Okay, 4 choose 0 divided by, again, all the possibilities of all the ways of choosing 4 out of 24. So now it will be this. So this is equal to 20 choose 4 times 4 choose 0. This is 1. I mean, if you do the calculation, you will see it's 1. Divide by 24 choose 4. Now, let's look at this one here now. C. Okay, 4 is chosen or solved anyway. We know it. Now, this time we want all defective. All defect means like 4 of them are defective. So we want 4 defective and 0 good. So what's the probability? Now again, we will look at the number of ways of choosing 0 good from 20 and 4 from 4. This is the probability will be now 20 choose 0 times 4 choose 4 divided by 24 choose 4. Now, okay, we can write this one here. So these are all 1 here. So if you calculate them, this is 1, this is 1. So I will just say here, the answer here is 1 divided by 24 choose 4. So you can calculate this one. Now let's look at the last one. In the last one, D, in the last one, it says at least 1 defective. So it means at least 1 defective. So at least 1 defective means it might be like 1, 2, 3, 4. So these are all, we will find the probabilities. But instead, it's better to go with the opposite of this, like we use the complement. At least 1 defective means the probability 1 minus no defective. At least 1 defective. Okay, it's the at least 1 defective, by the way. So let's say it's at least 1 defective. So this is just the opposite of no defective. And no defective means 4 good and 0 defective. So what does this mean? You choose 4 from 20 and 0 from defectives. So then if you can write it this way, this 1 minus the probability of this is now 20 choose 4 times 4 choose 0 divided by 24 choose 4. So this will be the probability for D. And you can do the calculations and get the results here. Now let's look at these examples. Find the value of A for the following discrete probability distribution. Now here is the discrete probability distribution. So
We know the sum of the probabilities will be equal to 1, so we can directly say A plus 0.25 plus 0.5 is equal to 1. So this will give you A plus 0.75 is equal to 1. And this will give you A is equal to 1 minus 0.75, which is 0.25. Now let's look at this example. Find the value of A for the following discrete probability distribution. Now here is the discrete probability distribution. So we know the sum of the probabilities will be equal to 1. So we can directly say A plus 0.25 plus 0.5 is equal to 1. So this will give you A plus 0.75 is equal to 1. And this will give you A is equal to 1 minus 0.75, which is 0.25.